Jeez, 162 people. Okay, this is going to be fun. Just give me a second, guys, just sorting out a couple of things. How are we doing for sound? Ooh, all right. Let's see. If this is actually loaded up. Yes, it is. All right, guys. So welcome to this penultimate tutorial for the MCAT. I have to say, was pretty surprised with the number of people actually waiting there. But look, let me just get straight into it. Just for those of you guys that are kind of still kind of worried about what do you call it, prep work and things like that, just remember that you guys can always go to my website. It is given in the description of this particular video. If you go into the website, just click on level 1 MCAT algebra, I think it is, if it works. Yep, there you go. All the revision material is actually in there. So this is, we're talking about past exam papers, talking about live tutorials that I do. Everything gets chucked up there. And of course, there's also the prep playlist for you guys to kind of work through as well. So there's lots of revision material for you guys over the next kind of, I guess, 2 days. So on a completely different note, I can't keep up with the chat, guys, because there is just way too many comments that are going up. So I will probably try my best to try and answer questions. But if I miss one of your questions and it's like really bugging you, then just send me an email, and that's going to be in that email address is also in the description. Okay, so let's get started with today's little tutorial. So first off, I just want to say big thanks to Walker Mats, because those guys actually gave out this paper for a good practice for all the teachers around New Zealand. So in that sense, it's, it just makes things a little bit easy for us to kind of have a go. So if you're wondering about the questions that we're going to work through, that link is also in the description. And so this is what the paper that I'm going to work through today. All right. And after that, I'm going to call it as always, guys. Rahil, unfortunately, the competition got extended, man. So it's actually extended to October 5th now. So I got to wait for a while. Now, one of the things, guys, is that these questions that I'm doing today, I've been given an answer schedule for it, but not like whether it's achieve merit or excellence. But as always, I'll go through the full questions. And if chat gets a bit too crazy, then I'll just put like slow mode on if I have to, if I can't keep up. Cool. So let's get started with this first question here. So starting off, damn, screenshot is not good, is it? That's all right. We'll just have to work with this. So what we've got here is we've actually got 2x plus 1 equals to 32. Nice and kind of easy question to kind of like start the paper with in this case. So as always, remember on the side, put down your 2 to the power of 1, which is 2. 2 squared is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. And if you keep going, eventually you're going to get 2 to the power of 5 equals to 32. So if that's the case, then what I'm going to do is I'm going to replace this 32 with 2 to the power of 5. So when I do this, I'm going to get 2 to the power of x plus 1 equals 2 to the power of 5. And at this point, because I have the two bases that are the same, then basically that means I can say that the power is equal to each other. So I can rewrite this as x plus 1 equals to 5. Or x is equal to 5 take away 1, which gives me an answer of 4. Cool. So I think that was the first question there. So we're gonna kind of move on Usually I'd actually say if there's any questions, but like I tell you guys, it is pretty challenging to keep up with the comments. So we're going to go on to the next question here. All right, so question 2, what we have is we've got yeet. No, you won't. Actually, that's not a bad idea, guys. So if you do have a question, can you just tag my name, please? Because then it pops up with something that I can actually read. Otherwise, it's just too hard to actually keep up with the chat. I can change it to slow mode if you guys want. Okay, give me 1 second. I think that was probably an achieved question, this one here. But then again, it does have 2 steps, so I'm kind of wondering whether it's actually achieved or a merit as well. Like, I'm kind of tossing up between that one. Give me 1 second, guys. Just sorting out one other thing here. Let's just see if I can set it up. Let's see. Options, no, classic streaming it is. Sorry, I can't figure it out at the moment because they've changed to new things. All right, that's fine. Let's actually go into the second question here. So second question is you've got 2x squared minus x minus 15. So you've got to actually factorize this. So factorizing this is the first step. What I want to do is I want to go 2 times negative 15 to get negative 30. And I'm basically looking for 2 numbers that multiply to negative 30 and add up to negative 1. So in this case, it is going to be negative 6 and positive 5. Because negative 6 times positive 5 is negative 30, and then when you add it up, you're going to end up with negative 1. So what I'm going to do is I'm going to rewrite this equation here as 2x squared minus 6x plus 5x minus 15 equals to 0. Now guys, you can actually put it put the 5x first or the negative 6x. It doesn't matter which one you do. They still should factorize. Like when you, in the end, when you actually solve it, it should still be it should still work out. So what I'm going to do is I'm going to split this up. So I've got 2x squared minus 6x. I'm going to split that up first. So what I have is 2x as a common factor, so it's going to be x minus 3. And then in this side I've got 5 as a common factor, and I've got x minus 3 as what's going to be inside the bracket. So at this point I could see that I'm going to get 2x plus 5 and x minus 3. So I'll take out x minus 3 as a common factor first, and once I do that, what I have is I've got 2x and 5 that's actually left over, which means I'm going to get 2x plus 5 equals to 0. So at this point I can say that x minus 3 equals to 0, or 2x plus 5 equals to 0. So when I solve this, I'm going to get x equals to 3. And when I solve this one, I'm going to get 2x equals to minus 5. And x equals to negative 5 over 2. So Justin, that's the kind of method we actually do for this type of factorization, is that you've got to multiply the first, the coefficient of x squared and the constant by itself. Is this a merit question? I'm tossing up again, man. Like maybe, no, I think it's probably a merit question, because you're factorizing and solving it. C Latu, no, you can actually leave it as -5/2, or you can leave it as -2.5. It doesn't matter. You should be all right. All right, so we are going to the next question. So with this question, guys, what I'm going to do is I'm going to give you guys maybe a couple of minutes just to have a go at it first. Emily, there are other ways, Emily, like you can actually, yeah, there's a couple of other ways that you can do it. But yeah, I would, because when you get to level 2, you learn a completely different method, which is like the quadratic formula, which makes things so much more easier to work on. So Saggy, this exam paper is actually available on my description, man. So have a look, and you can actually go ahead with these questions. Emma, I think the only place that you need to keep in mind is for chance and data. But for level, for MCAT, you can actually leave your answer as a fraction. Ashford, I don't know if I'll have enough time, man. Aspect, I saw your question that ends up being 2x minus 1's whole squared. Wait, I've set it up. I just haven't had time to play around with my new computer yet. But eventually, yeah, trying to set up a few things here. All right, so let's actually go through this question here. All right, so with this question, what you want to do is you want to actually get rid of all the numbers and rewrite them as base of 7. That's the idea behind it. So what we're going to do is we're going to call this 7 to the power of 4x plus 7 divided by 49 is 7 squared, and this is equal to 7 to the power of x squared. So the next part is actually getting rid of that 7 squared. So what you could do is you could rewrite this as 7 to the power of 4x plus 7, and we're going to write this as minus 2, because remember that when you have something like this, a to the power of m divided by a to the power of n, this is the same thing as saying a to the power of m minus n. So once we have that, then what we can do is we can still have this equal to 7 to the power of x squared. And on the left hand side, we've got 7 to the power of 4x plus 5 equals 7 to the power of x squared. So at this point, you can kind of see that the two bases are the same, and we can then say our powers are going to equal to each other. So we're going to get 4x plus 5 equals x squared. Rearranging this into a quadratic, we're going to get 0 equals x squared minus 4x and minus 5. So at this point, we can actually factorize this quadratic, and we're going to get x minus 5 and x plus 1. So, and because of that, we can say that x minus 5 is equal to 0, or x plus 1 equals to 0. So our first answer is going to be x equals to 5, and our second answer, x is equal to -1. That's just a very long arrow. Is this an E question? 2 years ago I would say yes, definitely E question. Emily, I think if you take it as negative x squared, then it's doable, but it's just a little bit more harder to factorize with negative. So Charlotte, I've seen this question like for the last couple of years where they've been putting quadratics in exponential. Sharon, that's factorizing the quadratic, man. I've just factorized the quadratic there. All right, guys, just kind of helping out with a few things. Section 2. Corin, I'm not sure which part is section 2. Nathan, look, I've got to keep going on with these questions because I want to try and wrap this up in about an hour. Word questions, but the paper that I'm actually working on has got a lot more skills to kind of work on, and then some word questions in there as well. Saqib, I think I've done it in the tutorials before, so yeah, we'll move on to the next question here. The answers to this, I can chuck it up for you guys. Let me put it, where can I chuck it? I'll actually put it in the description, guys, answers as well. Just give me a second. Cool. So let's have a look at this question here. Question D1, part of 1 is that you've got this block of wood is a cuboid and the measurements are shown. Write an expression for the sum of all of the edges of the cuboid. So basically what they're asking for is they're actually asking for well, if it's a two-dimensional shape, we're looking at a perimeter. I guess in this, because it's a three-dimensional shape, we're going to try and calculate all the edges. So we're going to try and add all the edges up together. All right. So the way to go about it is, if you have a look at it, you've got 4 of these 3x minus 1s. Then you've got 4 of the 2x plus 1s. And the 2.5, once again, you've got 4 of them there. So all we're really doing is we're simply multiplying by 4 with 4 times 3x minus 1 plus 4 times 2x plus 1 plus 4 times 2.5. So as you can see, those are the various sides that we have to actually work with in this particular in this cuboid. So expanding these brackets, you've got 4 times 3x, which is 12x, 4 times negative 1, which is negative 4, plus 4 times 2x, which is 8x, 4 times 1 is 4, and then 4 times 2.5 is 10. Tyler, how do I get the 4? Because there's actually 4 of those sides. All right. So next part is actually putting this all together. So we're going to collect all the like terms. So in this case, we've got 12 and 8x, which is going to be 20x. And then we've got the numbers to deal with. -4 plus 4 is 0. And finally, we've got 20x plus 10 as the perimeter. Okay, so if we're okay with this question, we are going to go with the next question here. So next part of this question is, it's kind of connected, right? It's connected to that previous question. What it says is if the volume of the block is 140, find the value of x. So basically, is it possible to multiply the bottom values then by the top? Harrison, I'm not sure I understand your question. Hugo, no, it's just says write an expression, so you can actually leave it as 20x plus 10. Cool. So with the next question, what we have is we've got volume of the cuboid first, right? So volume of a cuboid is going to be base times length times height. Well, you know, it depends on which perspective you actually have to look at it. Shaky, no, you don't have to solve for x in this case because they haven't actually given us what the perimeter is. So we don't need to actually worry about it. So if that's the case, what we have is we've got volume, which is equal to 140. We've got, I mean, like I said, it doesn't matter which way you look at it, but it's basically those three colors that we had in the diagram before. So we've got the base, the length, and the height. So we're just going to replace those things. So what we're going to get is we're going to get 3x minus 1 multiplied by 2x plus 1 and multiplied by 2.5. The volume question, I would say it is most likely an excellence question. Yeah, sorry. Okay, cool. So going with this part, like, you know how we've got this 2.5, right? So with the 2.5, it's kind of annoying to deal with 2.5 because if I take 2.5 to the other side, I'm going to end up with 140 divided by 2.5. So it's like, it's kind of messy to work with. So what you could do is, instead of working with 2.5, you could actually replace it with 5 over 2. And I'll show you guys why. Because when we actually take 5 over 2 to the across to the left-hand side, we can rewrite this as 3x minus 1 multiplied by 2x plus 1 equals 140 times 2 over 5, because dividing by 5 over 2 will be the same thing as saying multiplying by 2 over 5. Now the reason why I wanted to do this was because it makes it easy for me to work with these numbers. Now I wouldn't want to do 140 times 2 first. I want to do 140 divided by 5. Cool. So for those of you guys that are wondering how I got the 2 over 5, because if I was to do this 140 divided by 5 over 2, remember this is the same thing as saying 140 divided by 5 over 2, which means this is also the same thing as saying 140 multiplied by the reciprocal of this, of 5 over 2, which equals to 2 over 5. So that's all I've done there. The other way of looking at it is this right here. So you could have actually had 140 equals 3x minus 1 multiplied by 2x plus 1 multiplied by 5 over 2. So the first thing you could actually take is get the 2 across to the left hand side. So it becomes 140 times 2 equals 3x minus 1 multiplied by 2x plus 1 times 5, and now bring the 5 to the left hand side, and when we bring it to the left hand side it would become 140 times 2 divided by 5. So as you guys can see, it's the same kind of ideas behind the two of them, but it's just one of them is just kind of like stepping up skipping a couple of steps, that's all. Cool. So next part is we're actually going to try and kind of figure this out. So I'm going to start working from here. So 140 divided by 5 is 28. So I'm going to get rid of those two things and I'm going to replace it with 28. 28 times 2 is 56. So 56 equals this particular quadratic. So what I want to do is I want to actually solve this quadratic. So I'm going to have to actually do this the long way. So I've got 3x times 2x, which is, this is going to be a super annoying quadratic, but that's all right. 6x squared, 3x times 1 is 3x, negative 1 times 2x is negative x, sorry, positive, what am I doing? Negative 1 times 2x is negative 2x, and negative 1 times positive 1 is negative 1. Rian, it does help with having it as 5 over 2, but yeah, I mean, like, if you're comfortable working with 140 divided by 2.5, then you don't need to worry about it, right? Alright, so the next step is bringing that 56 across. So we're going to get 6x squared plus x minus 1 and minus 57. Now this, I have to say, is, sorry, 56 has to be a really horrible number to deal with, because you're going to get 6x squared plus x minus 57. Now I really hope that you guys don't get a horrible number like this, because solving this is like, it's just a pain. It's negative 57 because of the 56 and 1 putting it through later on. Yeah, as much as I hate this part of the paper, this is what we'll have to do. So at the moment what we have is we've got to think about yeah, see, like, one of the things I'm going to tell you guys is this: like, when you have got like really huge numbers, like in this case, what's actually worth kind of noting is learning about prime factorization. All right, like, prime factorization is always going to be helpful for you guys. So in this case, what we got to do is we've got to try and figure out two numbers that multiply to 57 and 6 and then add up to 1. So what I mean by that is you've got to take these two numbers and you got to multiply them together first. So we've got 57 and times 6, whatever that's going to be. So what do we got? 42 and 300. So that's actually 342. So I'm looking for two numbers that multiply to 342 and add up. So that's actually minus 342 and add up to positive 1. So the way I kind of go about it is break that 342 down as much as you can. So you can take down 342, break it down. Well, I'm going to kind of try and cheat here, because I'm actually going to use that 6 and 57, because then the 6 can be broken into 3 and 2. 57 could be broken into 19 and 3. And if you look at it, there is a link, like there's a little shortcut that you can try and figure out. So see these three numbers here? These three numbers add up to 18, and this number here is 19, so the difference is going to be 1. So the two numbers that I'm looking for is actually positive 19 and negative 18. So positive 19 and negative 18. So that 1x there, I'm going to split it up as positive 19 and negative 18. So, and I'm going to make it slightly easy for me. So I'm actually going to rewrite this as 0 is equal to 6x squared minus 18x plus 19x minus 57. And by doing this, what I'm going to do is essentially split them up into 2, and I've got 0 is equal to 6x, x minus 3, and then here 19 is a common factor, and I'm going to get x minus 3 again. So my two factors are going to be x minus 3 times 6x plus 19. So from here, I can say that x minus 3 is equal to 0, or 6x plus 19 equals to 0. So my first answer is x equals to 3. My second answer is I'm going to get 6x equals negative 19, and x is negative 19 over 6. John, I really hope that you guys don't get such a horrible number there, like how I did in this particular paper. Now, just to finish off the question, guys, we're going to say that x is equal to 3, as x can't be a negative number. Or can it? Let me just go have a look. 2x plus 1. Yeah, no. In this case, x can't actually be a negative number. All right, I'll try and answer some questions because I know there's a few questions on the thing that I just kind of saw. Karanveer, how do you get the negative 18? Well, the reason I went it to be negative 18, I got the negative 18 from here because 3 times 2 times 3 is equal to 18. But the reason I had to have it as negative 18 was because I needed this to be positive 1. And because it was going to be positive 1, the 19 plus minus 18 should equal positive 1. So that's why I made the 18 negative and not the 19. John, I answered your question. Shaky, I kind of answered that one as well. Yeah, Harrison, like, I hope they don't give, as I said before, I hope they don't give a number that big. Highlander, no, you don't need to simplify it any further because you're not really worried about that particular question. Cool. So, what if you put the 19x? Sorry, I just saw that, honey. What if you put the 19? It doesn't matter. It'll still factorize. So it's a really good question. Like I'm going to show you guys what happens if you put, instead of putting 18, you put 19 first, right? So what's going to happen is if you put the 19 first, you're going to get 6x squared plus 19x minus 18x minus 57, like this. And what's going to happen is when you split it up by parts, you're going to get x is the common factor in this case. So you're going to get 6x plus 19. And then here, minus 3 is a common factor, so you're going to get x plus 19. And then what you'll notice is you end up with 6x plus 19 multiplied by x minus 3. So it still works out to be the same. But yeah, sometimes it's trying to make things easy for you. Shaky, go check out my website, man. All the past papers are in there. Eugene, this particular paper it's actually in my description of this video. All right, guys, let's go to question 2. So, as always, you know, it's always nice to start off with a some basic questions for every one of those main questions. So what we have here is we've got find the value of this. We're just going to substitute it in. So we've got 3 negative 2 to the power of 4 minus 5 times negative 2 minus 4. Now negative 2 to the power of 4, we are going to get positive 16. So that's going to be 3 times 16 minus 5 times negative 10 is positive 10 minus 4. So what we have is we got 48 plus 10 minus 4, which equals to 54. So yeah, a bit of a substitution question that always seems to come every now and then. Will be an achieved. All right, so I'm guessing no problems with that, and we can go on to question 2b. No worries, Lumberjack. Orca, just got to be careful with this because sometimes people stuff up this. They put -2 to the power of 4 as -16. And then they'll make a mistake. Emily, I'm going to go through this whole paper, so we're in 2A. We've got another 9 questions to go. All right, so let's go to question 2. So question 2, what we have is, actually question 2B is a really good question to kind of have a look at it. Oh, Charlotte, the reason it's not -16 is because we've got -2 to the power of 4, which is -2 times -2 times -2 times -2, which means you're going to have, remember when two negatives, when you multiply, it ends up being a positive. So that's why it becomes +4 times +4, which equals to 16. So keep that in mind, all right? Cool. So question 2b, guys, while it looks like a really simple question, and this is a neat little something that you guys need to know, is when you're given a quadratic, all right, what if the power was -3? -3, current var, that's in level 2. You'll learn a bit more later. So what you have is, when you expand this quadratic here, we are going to get 4x times x, which is 4x squared. 4x times -3 is -12x. 3 times x is +3x. And 3 times -3 is -9. Now, it's really important to understand, guys, if you leave your answer like this, you are most likely not going to get your full answer. So it's really important that... Have I stuffed up somewhere? No, I haven't. What did I stuff up? 4x squared, -12x, 3x, -9. Yeah, if you leave it like this, you're not going to get an achieved mark. All right, you have to simplify it. And so when you simplify it, you're going to get 4x squared minus 9x minus 9. Oh, right. Sorry, I just saw my own question. I copied it wrong. Apologies. I was wondering why people were getting a different answer to me. So x minus 5. Let's try that again. So we've got 4x times that is 4x squared. Then we've got minus 20x plus 3x and minus 15. Much better. So we got to get 4x squared minus 17x minus 15. Charlie, there's a whole lot of tutorials up that I've put on my website, man. Just have a look at it. Yeah, so sometimes you can copy the question wrong, guys. So as you can see, I just copied the question wrong, but I guess because I did everything right, I would probably be kind enough to give the mark. Jonty, no, this will be an achieved. All right, so let's have a look at this next question here. '17th rat. No, got you, man. Cool. So with this question, it's asked you to write it as a single fraction. And the part that I'm going to ask you guys to be the most careful about in this question, there is a reason why this question comes up, and there's also a reason why this question ends up being a merit question. And that's mainly because of this little minus symbol there. All right. So the minus symbol, what happens is that when you guys actually work out these questions here, right? When you guys actually work out these questions, it's really important to understand that like you can do cross multiplication. If you kind of do cross multiplication, then what happens is that, you know, it does work out, not a problem. But the way I kind of work it out is this, and I write these questions and I pretty much give a little bit of space here. All right, the way to see this question is this. In the denominator, you've got x minus 4 and you've got x plus 1. So what you got to do is you got to make sure those denominators are the same, which means I need an x plus 1 in this left-hand side fraction, and I need an x minus 4 in the right-hand side fraction. So what I'm going to do is I'm going to multiply by x plus 1 and x plus 1. And as for the right-hand side fraction, I'm going to multiply by x minus 4 and x minus 4. And I'm going to be honest with you guys, this is where it really helps to put these in brackets, all right? So what we're going to do is we're going to do 5x times x plus 1 minus 3 times x minus 4. And the whole thing is by over same fraction, which is the yellow and the blue part, which is x minus 4 and x plus 1. Now, remember how I said that be careful with this minus sign. The reason is because that minus sign is going to affect both this x and also the negative 4. All right, so if we're going to expand these brackets, so we got 5x times x, which is 5x squared, 5x times 1, which is 5x. Then we've got the negative 3 times x, which is negative 3x. And negative 3 times negative 4 is positive 12. And in the denominator, we've got x minus 4 and x plus 1. So now the important part is actually simplifying the numerator. So we're going to get 5x squared. What else are we going to get? 5x squared plus 2x plus 12. And that's all divided by x minus 4 and x plus 1. So that is basically it for question C. You don't need to, you don't need to expand the denominator. You could actually leave it as it is, and that's absolutely fine. Okay, does the denominator stay the same? Brandini, yeah, the denominator, you don't need to really do anything about it. Currently, you don't need to worry about expanding the denominator because the question actually asks, write it as a single fraction. So you could potentially, you've done it. You've done this question as a single fraction. Tiger, did you not just do cross multiplication? Yes, you can do cross multiplication. It does work out as well, but in the long run, you want to find the lowest common multiple. Particularly at level 2, when these questions start coming up, it's best to know how to find the lowest common multiple. Butterfly fields, if you expand, you're not going to get any. You won't get marked down, so you can actually, you can leave it like that. Eric. If it's possible, you can factorize the numerator, but again, you have to go back to the question, right? The question actually says write it as a single fraction, and because of that, you don't really need to kind of like, unless it's like you genuinely see something there. But most of these types of questions, they tend to kind of just focus on you writing it as one single fraction. Yeah, I'm not sure you can actually factorize the numerator. Let me just check if it's even possible first. I don't think you can factorize the numerator, but I could be wrong. Nah, you can't factorize the numerator in this case. Yep, Nathan, you can just leave it as it is. Cool, so let's go to question D. Now we're starting to get into some new territory here because this, why doesn't the 5x get a negative? 5x doesn't get a negative. No, it wouldn't get a negative because the 5x just has the positive in front of it. So I don't think you can. It's only because of the negatives actually attached to the 3, not the 5x. The previous question was a merit, I would say. Young Hoon, the issue with doing the excellence question first is that trying to figure out which question is the excellence question, because the paper, they've actually changed things around quite a bit, like, so it's not as straightforward as what it was before. No, little biggie, you won't. Okay, so let's actually look at question D here. So question D, what we have is we've got a prep, and I think this is a good question to kind of have, guys, in the back of your skill set, because this type of question came a couple of times. So it's not a bad skill to actually have. So how do you do this question? 17 red? Yes, you can, but the problem is you don't know which one's there. The R, E. So in this question, what you have got is you've got a parabola, which is, wow, what's happening? Let's try that again. So the parabola is right there. That's your parabola's equation. And what you also have is you've got a straight line. And right now they're asking you to find the coordinates of the points where the two graphs intersect. So they want to know what those two red points are. I'm gonna try and squeeze that in there. That's the best I could do, Harrison. Otherwise, you can just click on the OneNote link in my description, man, and that should take you to this document, and so you can actually have a look at it. All right. So what we're gonna do is we're gonna put these two equations equal to each other. That's all you guys gotta do. All right. So when you get a question like this and they're asking you, find the coordinates, and they give you like a parabola and an equation or whatever. So you literally just put the two equations equal to each other. So you got 2x squared minus 3x minus 8 equals to 4 minus x. And at this point, what you want to do is you want to rearrange it so that one of the equation is equal to 0. So we're going to put this as 2x squared minus 3x. When I bring the minus x across, it's going to become plus x. And I've got minus 8 minus 4. And this is equal to 0. So simplifying this, I'm going to get 2x squared minus 2x minus 12 equals to 0. Now guys, not at all times you don't need to actually kind of do that whole multiplying the coefficient of x squared and the constant. So sometimes you might be lucky enough to get a question like this, but I doubt they'd give you a question like this in the MCAT this easy. But basically what you can do is, in this case, you can take out 2 as a common factor. So you're going to get x squared minus x minus 6 equals to 0. So at this point, get rid of the 2, because when the 2 goes to the other side, it becomes 0 divided by 2, and then 0 divided by 2 is just 0. So x squared minus x minus 6 equals to 0. Factorize this. I've got x minus 3, x plus 2 equals to 0. So I can say basically x minus 3 equals to 0 or x plus 2 equals to 0. So here's the part that's really important. It's actually asking you for the coordinates. Now if you want coordinates, you got to give the x value and the y value. You can't just give x value and be done with this question. All right, so you have to put it as x and y value, and so I'm going to choose the easiest one to do. All right, so remember, you can use either equation. You can use the quadratic equation to find the y value, or you could use the straight line equation. Now looking at this straight line equation is easy, because when x equals to 3, y is equal to 4 minus x, and y is equal to 4 minus 3, which means it's 1. So here's my first point. My first point is 3, 1. Then my second point, x equals to minus 2. So y is equal to 4 minus negative 2, which means I'm going to get y is equal to 6. And my second point is going to be negative 2 and positive 6. So then these are the 2 points where these parabola and the straight line actually meets. Karanveer, why didn't I do that is because, as you saw here in this line here, I can see that 2 is a common factor for all of those numbers, so I actually took 2 out. So you can still do it the other method. Orca, I reckon you'd get a merit if you just get x coordinates. Samantha, yes, this video will go up after this tutorial is finished. This question, yeah, I would probably say it's borderline excellence. I would say it's excellence because you are doing like multiple steps here. Cool. So I guess we're going to move on from this question. I would say E, man. Hamza, I would say E. Eric, 4 minus -2. So remember, when 2 negatives are next to each other, then they become positive. Cool, guys. Let's actually go to question E, because question E was like, I got a bit more room. Now question E here, it will be an excellence question, all right? But the way this excellent question works is that you've got to actually try and look at what's happening between the 2 equations. So in this case, what they're asking from you is they want M in terms of L. So they want you to try and show that somewhere that M is something to do with L. The only way to do this type of question is this. You've got to actually expand the brackets. Okay? Expand the brackets and actually simplify. So I'm going to do L first. So what I have is 2a minus 5. And I've got 7a minus 3 plus 21a. So expanding this, I'm going to get 2a times 7a, which is 14a squared. Then I've got minus 6a minus 35a. Just hope I'm on the right track here. Looks like it. Plus 15 plus 21a. So when I simplify this, I'm going to get 14a squared minus 41, and 21 is going to be plus 20a plus 15. So once that's done, now we're going to go do M. So M is now equal to 5a minus 4 squared plus 3a squared plus 14. So expanding the brackets, I've got 5a minus 4 times 5a minus 4 plus 3a squared plus 14. So M is equal to 25a squared minus 20a minus 20a plus 16 plus 3a squared and plus 14. Simplifying this, I'm going to get 28a squared minus 40a plus 30. How did I get 25a squared? 5a times 5a is shaky. Yep, sorry about that. Minus 20. Thank you for that. Got it. Man, you guys are harsh with me. All right, so at this point, how do we go about trying to write an equation for M and L? The only way to have a look at it is like have a look at both of those equations and see what's actually happening. Now, what you actually can see is, well, there's a couple of ways of doing this, right? Like last year they had a way, last year they had a different type of question. So I guess it's always good to kind of keep looking at this, right? So you've got 14, 20, and 15. Here you've got 28, 40, and 30. So what I could do is I'm going to take 2 out as a common factor here. When I take 2 out as a common factor, I get 14a squared minus 20a plus 30. No, plus 15. And what you should see is that this part right here fits in nicely inside this bracket. So then we can simply say that m equals 2 times L. Orca, how did I get negative 20a? I've got negative 41a plus 21a. That's how I got the negative 20a. So now these types of write this equation and this other equation, stuff like that. What's a really good idea is kind of just having a bit of a play around with this to try and figure stuff out. Emma, yes you are. I encourage my students to use highlighters for even if it's like level 2 and 3. I ask them to use highlighters in an exam. No, Butterfly, I'm assuming you're talking about this step here. You can actually skip this step. You can directly go from this line to this line. What if we subtracted m from L? If you subtract m from L, then you would still get L. Nate, I teach at Ormiston Junior College. Jonty, you've seen if you look at my exam papers, man, I use highlighters quite a bit in my exam paper revision material. You can kind of see how I use it, and you can kind of use that as a trick. This would be an excellent styler. Not sure, Charlotte, it's been a while since I've been to uni. Cool, so let's go to question 3, guys, and we've got 5 more questions and we're going to call it a night. Shaky, what I meant is 2 is a common factor in that 28, 40, and 30. So that's all I did. I took 2 out as a common factor out. Could you write L equals m over 2? Corin? No. You're correct. You're absolutely correct, Corin, but the problem is the question's actually asking m in terms of L. So you've got to put m equals to something. When you do L equals m over 2, you're actually writing L in terms of m. Okay? So just be careful with that one. I'll talk a little bit more about that, Campbell, at the end, all right? Okay, so let's go with this question 3 here. So what we've got is a rearranging question. So we've got pi r squared h, and what we want is give the equation for r. So basically we want to have r by itself. Gonna get rid of the pi and h to the other side. When I bring it to the other side, it will be divided, and then finally r could be written as square root of v over pi over a, pi times h. Vrishank, no, it'll be saved, man. It'll be saved, and I'll put it up next to my exam paper revision question stuff, so you can have a look through it later. Positive 21a from. Just going back to that was part of the question. It came with the question. Emily, that rearranging question would be unachieved for question 3a would be unachieved. Brick Monster, controversial. You could put it as plus or minus. It wouldn't really matter in this case. But yeah, you could always put plus or minus as well. Nate, it's a long story. I was supposed to make a video for that back in January when I hit 10k subs, but I will get to it, but I just get carried away with the actual work and I forget. 3 dots thing matter? No, Yeet. The 3 dots basically just means it's another way of writing therefore. That's all. Okay, so we are going to question B here. So question B here. Yes, Orca, that is the answer. You don't have to worry about anything else. Nathan, you're right. You can actually put it on the right hand side. It equals. You know, it's like saying, you know, if I tell you that 3 plus 2 equals to 5, it's the same thing as saying 5 is equal to 3 plus 2. So, you know, your teacher's not wrong in saying that R should be on the left hand side. Generally, it's etiquette in mathematics that we actually put the thing that we're trying to find on the left hand side. You'd be correct there, Lola. No worries, Nate. Okay, cool. So let's get to this next question here. Solve the inequality. So what we've got is we're going to expand the brackets. Now these questions here, the inequality questions, they all follow the same rules as equal signs. So numbers, if you're working with numbers, it's a really good idea to put a plus or minus, but formulas, not so much that you need to worry about yet. Yeah. So expanding the brackets, you got 3 times 2, which is 6. 3 times negative 5x, which is minus 15x, minus 9x, greater than or equal to negative 6 times 2x is negative 12x, negative 6 times 3 is negative 18. So kind of rearranging this now, so we've got 6 minus 24x is greater than or equal to minus 12x minus 18. I'm going to bring the the x's together and get rid of the numbers. So negative 12x, when it comes to this side, it becomes plus 12x. 6 when it goes over to the other side, it's minus 6. So what you end up having is negative 12x is greater than or equal to negative 24. Now this is the part that's really important. So remember that when you divide by a negative number, you have to change the sign. So this will become negative 24 divided by negative 12, which means the final answer I'm looking for is x is less than or equal to 2. I think it's the last question today, Karan Veer, when we're doing an excellence question. No, Orca, this will be a merit question. So what's the difference between the two signs again? Basically, well, it depends how you put it, right? So this is saying x is bigger than 2. This is x is less than bigger than or equal to 2. And then here you got x less than 2, and then x is less than or equal to 2. So greater or equal, less than, less or equal to. Wait, there's a few questions. In 3b, if I don't put the or equal to line underneath the greater than sign, do I get marked down? Yes, Shaky. You've got to put that equal sign underneath the less than symbol. Otherwise, it becomes a less than 2, and that's not correct. Wade, I'm not sure yet. Kind of tossing up about it because I really don't have any questions at the moment, apart from heaps of questions from kids that I got to do. Yes, Emily, you pretty much treat it like a equal sign, and the only time you change the symbol is when you divide by a negative number. So notice how I actually divided by a negative number. That's the only time you need to change the symbol. Otherwise, you treat it exactly like the equals. Could you times both sides by positive 1? Harrison, if you multiply both sides by positive 1, I don't think we can change. Nothing will change. So, no, I think the less than or equal to, changing the sign and writing the right answer is gets you merit, Kashi. Tomorrow night, don't know, guys. I'll see see how I go. No worries, Luke. Happy to help. Do only change. Okay. Let's just see. No, butterfly, if you divide by a positive number, you wouldn't change the sign. All right, guys, we are going to question C here. Florian, once I stop the stream, it'll get saved and you can have a look at it. It should be available. Geometrics, I'm still kind of thinking about it, whether we actually do one tomorrow or not. All right, so this question here, and I think, who was it? I think it was Karanvi that keeps asking me this. Why don't you do 2 times negative 36? In this particular case, I'm not going to go 2 times negative 36 to try and solve this. What I can see is, because in the numerator, I can see that 2 is a common factor. Somebody else was asking me about how do you know it, so I think it was Shaky. So I'm going to take out 2 as a common factor and rewrite this as x squared minus 3x minus 18 over x squared minus 9. Now, really important, guys. What you have to do is, like, don't just start canceling things out here. You've got to make sure that you factorize first before you actually do any kind of work here. Yeah, so the top part, I'm going to factorize it because that's actually x minus 6 and x minus 6 and x minus 3, x plus 3, sorry, because you're going to have negative 6 plus 3 is negative 3 and negative 6 times 3 is negative 18. As for the denominator, it's x squared minus 9, so I'm going to rewrite that as x minus 3 and x plus 3. Here I can see that x plus 3 are common factors, so I can get rid of it. And then what you have is your final answer is 2x minus 6 divided by x minus 3. L, do you change the normal greater to less than sign when dividing or multiplying? So going back to that question, L, like, you only change the sign, the direction of the sign, when you divide by a negative number. Yep, you're on the track, Kashi. Yep, Emily, it should still be same. I think one of your values would end up being like 2x minus 12, or it could be like 2x plus 6. So you still have to kind of try and factorize it a bit further. I'm not sure how you... Ruben, can you just type in what your other answers were, and I'm going to try and help you out. Yujing, you don't need to worry about the numerator. You could leave it like that, or you can expand it again. Because again, the question that they're asking for is simplifying. So, you know, you've simplified the fraction, and therefore it should be all right. Nate, just practice, practice, practice. That's all I can say. Krish, the reason this chat is on slow mode is because, man, I couldn't keep up with the question. All good, Matt Slab. Haven't seen you in a while, Matt, but yeah, I can imagine, mate. Busy with the baby, I can always understand. Managed to get my kid down to sleeping at 7:30, so we can actually do some work. But we'll try and figure something out, buddy. Can you press Windows X? Okay, at step 1, could you just factorize it straight away? Step 1. If you can factorize it straight away, then yeah, sure, why not? Yes, Lucas, you can still do that, but I think you'll have to do one extra factorization, but it'll still work. Shaggy, never worry about asking questions, man. Like, some people have questions they ask, so just keep asking. Now, I don't think you'll be wrong, Karanveer, if you were to do that. But it just the problem will become a lot more like you would have to actually work on a bit more. No, that's the final answer. Cool. Let's actually go to the next question. No, we're not allowed calculators in this question in this paper. All right, so here we go. Next question. third line of working. 1, 2, 3. Factorize, man, factorize. It's a quadratic, you got to factorize it. Who was it that I saw it from? Third line. I missed that comment. It just gone by now. Cool. So let's go to this question here. What we have is this is a, like, how do I put it? It's not a bad question, but people just kind of get confused with it all the time. I don't know why, but basically this is the idea, right? And I think this is a really important thing to kind of understand. When we're talking about one solution, all right, basically what they're saying is, see, let me just show you guys. This is what two solutions look like. So when you have two solutions, when you factorize, you're going to have something like this: x plus 3 and x plus 1. Therefore, x equals to minus 3 and negative 1. So that's an example of two solutions. When you want one solution, it's going to look like this: x plus 3 times x plus 3. It basically means that you're going to get two brackets that are going to be the same. All right, or it's a square number. That's all. That's the way to think about it. So if you think about it, like there's like so many ways of doing this. Like the easiest kind of way to look at this is looking at it as a square number. But in this case, what we have is x squared minus 14x plus c equals to 0. So what we want is, we want this two numbers to be the same. And the way we can actually do it the same is that it has to be -7 and -7, because the -7 plus the other -7 is equal to -14. Therefore, sorry, the 3 dots means therefore. So if we were to expand this, what we're going to get is x squared minus 14x plus 49 equals to 0. So in other words, we can see that c. So we can see that c is equal to 49, and the solution is 7. Can't we use discriminant d equals to 0? Interesting question there, Shrey, but the level 1 MCAT paper, they are assuming that you have not actually understood what haven't done discriminant or a quadratic formula. That was actually a discussion that we actually had quite a while back. What happens if kids use a quadratic formula for the MCAT? So yeah, this is a merit question. Yes, I would say it's a merit question. Denishan, yeah, Walker Mats actually donated a paper, so we've kind of been working through it. So guys, last question for the night, and to kind of finish off on an easy one here. Fletcher quadratic formula is worth knowing. It's always worth knowing that formula, but for level 1 MCAT, you can try and do it without it. All right, so here we're going to kind of finish off with a really do you have to state square number gives only one solution? Look, that's not a bad idea to do that. You can actually do that. It's to say that a square number actually only gives one number. Cool, guys. So what we're going to do is, we've got this last question. I mean, compared to some of the simultaneous questions you guys have been getting, this is don't worry, Oka, it's not too bad. Writing the equation can actually get you some easy marks, and then after that, just solving it is the next thing. All right, so the way I kind of approach simultaneous equations is I always create a little table. Just helps me with seeing things a little bit more clearer. So what we have got is, we've got 16 people, we've got adults and children, and what is it, $15 for adult, and we've got total cost is 163. So the table I'm going to make is, I've got adults there and we've got children, and I'm going to create this as number and cost. So basically, the number of adults, well, we don't know what that is, so we're going to put that as A. Number of children, we have no idea, that's C. But we do know what the total is. because totally we've got 16 people are visiting the zoo. All right, then we've got $15 per adult for the ticket, $8 for each child, and that group is paying $163. So basically what we have got is two equations. Our first equation is this, and our second equation is this. So we can actually say A plus C equals 16, and 15A plus 8C equals 163. So if that's the case, then in this particular one, rather than eliminating, what we can do is we can do substitution. So what I mean by that is we can actually rewrite A as 16 minus C. And then what I could do is I could substitute, wrong color to use, I'm going to use this one here. So because A equals to 16 minus C, I'm going to replace A there. So then we can actually rewrite this as 15 multiplied by 16 minus C plus 8C equals 163. So what we have is 240 minus 15C plus 8C equals 163. And kind of rearranging this, we're going to get negative 7C equals 163 minus 240. And what we have is negative 7C equals 40 plus 33. What have I done wrong here? (37) and 47 is negative 77. And C is negative 77 divided by negative 7. And C is equal to 11. And I think the question asks how many children were there, which is 11. The 240 is from 15 times 16 is 240. 15 times negative C is negative 15C. Melanie, you can actually use X and Y. That's absolutely fine. Just as long as you actually mention that adults is X, and or if you use child as X, then you could do that as well. Yeah. Oh, sorry, I didn't read the rest of the comment there. Yep, you're all fine. Elimination will work. Yep, you could do that as well. Campbell, this one, I have to say, man, it used to be like an excellence question, but now it's like a merit question. Or excellence, I don't know. They keep changing it around. That looks like... Alright guys, look, that's pretty much it for today's coverage. I will actually leave this up for you guys to kind of catch up with later. If you do need any more revision material, as I said to you before, go to my website. Particularly that MCAT prep playlist. There is so many questions out there for you guys to kind of have a play with, just watching this. Gosh, this is not a 2020 MCAT paper. I've not seen it, man. YM, I don't think I'll be able to do the tables graphs before Wednesday. I've got reports to write first. So guys, I will let you know mid-afternoon tomorrow whether we'll be running another tutorial for tomorrow night. Nate, don't skip any questions. Just before you guys head off, don't skip any questions, all right? Just make sure that you guys write, even writing something like a formula that you think that it might be right, you might actually be on the right track. So we'll talk a little bit about strategy tomorrow in terms of how to handle the paper and stuff like that. But I'm going to keep a really short session tomorrow. I don't want to spend too much time going through questions tomorrow, if that means. All right, guys, that's basically it from me today. Go back, watch those exam papers. Make sure that you just keep trying some of these questions, all right? Even those word questions, just go through them again and again, practice it. That's all I can say. And I will catch you guys tomorrow for the last run. Senpai Calculus Level 3 tutorial. Maybe I'll open up a help desk, man, so you guys can just bring in questions and we'll try and work it out. We'll kick off at 7:30 tomorrow, guys, as always. Thank you. Long session today, and I will catch you guys later. See you later, guys.